In the previous video, we looked at building a bag of words model to formulate a histogram for machine learning algorithms. In this video, we're going to take a look at categorizing text documents into different classes by building a text classifier. The goal of text classification is to categorize text documents into different classes. This is an extremely important analysis technique in NLP. We will use a technique which is based on statistic called TF-IDF, which stands for Term Frequency Inverse Document Frequency. This is an analysis tool which helps us understand how important a word is to a document in a set of documents. It serves as a feature vector that's used to categorize documents. You can learn more about it on this website. Let's first create a new Python file and we name it tf-idf.py. Next, we import the fetch20 newsgroup package. Now let's select a list of categories and name them using dictionary mapping. These categories are available as part of the newsgroups dataset that we just imported. Then, load the training data based on the categories that we've just defined. After this, we import the feature extractor. Then we extract the features using the training data. We're now ready to train the classifier. So we'll use here the multinomial naive Bayes classifier. Next, define a couple of random input sentences. Now define the TF-IDF transformer object and train. Once we have the feature vectors, train the multinomial naive Bayes classifier using this data. As you can see, we have done this in the preceding lines. Let's transform the input data using word counts. Also, transform the input data using the TF-IDF transformer. Now, let's predict the output categories of these input sentences using the trained classifier. Finally, we add these lines of code to print the outputs. So let's run this code and check the output. So you can see this output printed on your terminal. Let's now understand how did it work. The TF-IDF technique is used frequently in information retrieval. The goal is to understand the importance of each word within a document. We want to identify words that are occurring many times in a document. At the same time, common words like is and be don't really reflect the nature of the content, so we need to extract the words that are a true indicator. The importance of each word increases as the count increases. At the same time, as it appears a lot, the frequency of this word increases too. These two things tend to balance each other out. We extract the term counts from each sentence. Once we convert this to a feature vector, we train the classifier to categorize these sentences. The term frequency, TF, measures how frequently a word occurs in a given document. As multiple documents differ in length, the numbers in the histogram tend to vary a lot. So we need to normalize this so it becomes a level playing field. To achieve normalization, we divide term frequency by the total number of words in a given document. The inverse document frequency, IDF, measures the importance of a given word. When we compute TF, all words are considered to be equally important. To counterbalance the frequencies of commonly occurring words, we need to weigh them down and scale up the rare ones. We need to calculate the ratio of the number of documents with the given word and divide it by the total number of documents. IDF is calculated by taking the negative algorithm of this ratio. For example, simple words such as is or the tend to appear a lot in various documents. However, this doesn't mean we can categorize the document based on those words. At the same time, if a word appears a single time, that's not useful either. So we look for words that appear a number of times, but not so much that they become noisy. This is formulated in the TF-IDF technique and used to classify documents. Search engines frequently use this tool in order to search results by relevance. In this video, we've built a text classifier to categorize text documents into different classes. In the next video, we'll see how to identify the gender from the available text data.